Good morning, happy Wednesday. I wanted to share a couple of things before you take your unit test today. So your unit test is covering everything from unit 7, so that entire workbook. And we're talking really all those exponent rules, which we actually call the laws of exponents, and then working with scientific notation. So I wanted to cover a couple of things that you might see on your test today. So I'm going to go ahead and share my screen here. And the first thing that I want to remind you of is that last week you were given these exponent rules. So you went through lessons 1 through 5, and then at the end of lesson 5, I asked you to copy some rules into the notes section of your workbook. And that's just what's on this paper here, that PDF that I shared. And as I said a minute ago, we really call these the laws of exponents. Okay, so going through when the bases are the same. Okay, and again, this number here is called our base. This number here, or in this case, it's a variable, is called our exponent. Okay, and when our bases are the same, we add the exponents. When we take a base to a power, and then we say we raise it to another power, the law of exponents is that we multiply those two exponents. Okay. The third law of exponents that you learned was that when we are dividing and our bases are the same, we subtract those two exponents. We also talked about anything raised to the power of 0 is equivalent to 1. And then when we have a base raised to a negative exponent, that's the same thing as a numerator of 1, and then our number becomes 10 to the positive variable of n. That exponent becomes positive when we move it into the denominator. And so these negative exponents, what's really important to remember about that is it's just a really, really small positive number, a number between 0 and 1. Okay, so they are small, but they are still positive. So just because the exponent is negative does not mean we have a negative outcome. It means we have a small decimal or a small fraction between 0 and 1. And so you might see some questions like this on your test, but I also want to really draw your attention to this rule here and this rule here, because those show up again at the end of your unit when we're talking about scientific notation. So you do some work where you're multiplying numbers in scientific notation and some where you're dividing numbers in scientific notation. And so these two laws of exponents come up again when we're working with scientific notation. So this idea of multiplying when our bases are the same, we're going to add the exponent. And when we're dividing numbers where the base is the same, we're going to subtract the exponents. Okay, so that was the first part of our unit, was talking about all the different laws of exponents. And again, this PDF was shared on Google Classroom, so you can always refer back to it from that lesson 5 from unit 7. Then we transitioned into work on scientific notation. And so there are a couple things that I really want to point out to you that are special about scientific notation. So you covered this maybe briefly in science earlier this year, but the purpose of scientific notation is when we're dealing with really large numbers and then these very, very small numbers, we want to find a way to write them where we can eliminate having to have all these zeros at the end of a large number, or you have 0 point and a bunch of zeros before you actually get to some non-zero digits when you have a really small number. So in order for something to be in correct scientific notation, it has 3 parts, okay? So the first part is we have one non-zero number in front of the decimal. Okay, so that's really, really important. We don't consider anything to be correctly written in scientific notation if there is a 0 in front of the decimal or if you have more than one number. Okay, so we're really focusing on one non-zero number in front of the decimal. That's followed by a multiplication symbol. Okay, you might see this as that multiplication that looks like an X. Khan Academy, because that X is typically a variable, oftentimes it's just represented with a dot. Okay, but something to signify multiplication. And we follow it by a power of 10. So 10 to the power of 2, 10 to the power of -4. You have some base of 10 raised to an exponent. So those are the three key parts. Now, in working with scientific notation, I just wrote two things here that might be a nice hint or reminder as you're working with scientific notation. Anytime you're moving your decimal to the left, it is increasing your exponent, okay? And if you're moving to the right, that's causing your exponent to decrease or go down, okay? And I'll talk about some other helpful reminders as I go through a couple examples with you. So the first thing is just, can we identify, is something in scientific notation? Is it correctly written in scientific notation? So I'm gonna go through a couple examples here, okay? Making sure that I'm finding all three of my important pieces, okay? So these being my three important pieces, 5 and 23 hundredths times 10 to the power of 8. So my first thing is, do I have one non-zero number in front of the decimal? Well, the only number in front of my decimal is a 5. So I only have one digit, and it is not a 0. So that part looks great. I need to follow it by a multiplication symbol. That happens right here. So check, right? We have that non-zero number in front of the decimal. We have that multiplication symbol. And then we have a power of 10, a base of 10 raised to some exponent. Check. So this first one is in correct scientific notation. Okay, so state whether it's in scientific notation. Yes, this one looks great. Now I'm going to jump down to 2. Okay, 48,200. This isn't written in scientific notation at all. I don't have a decimal represented anywhere here. I don't have a multiplication symbol, and I don't have a power of 10. So it says if it's not in scientific notation, we need to write it in scientific notation, okay? Anytime I have a number, which we call a whole number, okay, there's nothing remaining, there's nothing left over, my decimal goes at the end. I'm gonna switch to red. So this is a little clearer to see, okay? So it's at the end, and I am going to move it, okay, until I have one non-zero number. So in this case, that's going to be my 4. Okay, I want just the 4 to be in front of the decimal. So I need to count how many times am I moving this decimal, because that's my exponent. Okay, so I'm moving 1, 2, 3, 4 times to get my number, or my decimal rather, from the very back of my number to in between the 4 and the 8. So that's 4.82. I need to include all of the numbers up until I get to a bunch of zeros. Once I get to those zeros that are just placeholders, we drop them off the end there. So now I have one non-zero number. I need to add my multiplication symbol, and then I need to write a power of 10. Okay, so I gave you some hints here about powers of 10. So we moved it to the left, which is going to mean my exponent is going to go up. The other hint or trick that I always think of when dealing with scientific notation is if I started with a big number, and big is a little bit relative. I'm talking about anything greater than the number 1. If I start with a number larger than 1, my exponent is positive, okay? So I've moved 1, 2, 3, 4. I started with a really big number, 48,200. So my exponent is positive 4, okay? We call this scientific notation. We call this form standard form, okay? So that's one example. Let's look at 3. It's also not in scientific notation, so I have to write it in scientific notation. So I'm given a decimal because this is a rather small number, a positive, tiny number. And so I need to move that decimal so that I have a non-zero number in front of it, okay? And that's going to be that 9, okay? So I want to end with 9.9. All right, so let's start moving. I'm gonna move 1, 2, 3. Oh, again, I'm moving 4 times, okay? So I have 9.9. I need my multiplication symbol. And now I'm gonna write my power of 10. But because I started with a very small number, a number less than 1, or if you can think of it, I am moving my decimal to the right, my exponent is actually going to be negative, okay, to represent that small number less than 1. So this is going to be represented as 10 to the negative 4. We can go through and look at a couple more. This one almost looks like it's in scientific notation, but it's not because I have my multiplication symbol, I have my power of 10, but I don't have one number in front of the decimal. I don't even have a decimal here at all. So I am going to put my decimal at the end, okay, because 36 is a whole number. But I need to have my decimal between the 3 and the 6 so that it is in correct scientific notation. I need that one number in front of my decimal. Now I move my decimal to the left. So I am increasing my exponent. So it's going to push that 10 to the 5th to become 10 to the 6th because I moved it 1 time. So I bump it up from 5, 1 up to 6. Okay. For this one, I have a number that is not 0, just one of them in front of the decimal. I have that multiplication symbol, and I have 10 raised to an exponent. So this is incorrect scientific notation. And then this last one, okay, my number in front of the decimal is a 0, and that is not correct scientific notation. So I'm going to have to bump this decimal back 1, so it's in between the 7 and the 8, so 7.8. Okay, and I can say these are equivalent, so I'm going to add that equal sign. Okay, they're equal values. So now I have 7 and 8/10 times 10, and now I'm going to have to decide what's going to happen to this exponent. So I'm actually decreasing, I'm moving it to the right, I'm decreasing the exponent, so it needs to go down 1, and from -3, I'm getting further away from 0 on the number line. So this goes from -3 to a -4. You can almost think about if I had started with this kind of a number, and you could imagine that this person made a mistake and only moved the decimal 3 times to the right, but they should have moved it 4. So it was in between the 7 and the 8. Okay. I'm not going to spend a lot of time here. I'd like to talk a little bit about the operations with scientific notation. So here, writing each number in scientific notation just means you want to make sure you have all 3 of these pieces, okay? That non-zero number in front of the decimal and only 1, a multiplication symbol, and then a power of 10 raised to a positive exponent, raised to a negative exponent. Maybe it's even raised to 0, okay? Maybe you don't need to move very much at all, okay? So 10 to the 0 means I didn't have to move it to the left or the right, but maybe I really need to express it in scientific notation, so I just keep it as that 10 to the power of 0, okay? Whenever you're asked to write in standard notation, or sometimes it's called standard form, okay, that means you want to write it the way these start, okay? So if I have a negative exponent, it means I started with a really small number, okay? In order to make 3 and 5/10 small, okay, I'm going to have to move that decimal to the left. It's telling me to do that 4 times, okay? So if I have 3 and 5/10, and I need to move it 4 times to make this a small number, less than 1, I'm going to move 1, 2, 3, 4, and then I just fill in zeros. So this number is actually in standard notation 0.000335. Okay. So again, I started with a negative exponent, which means my final answer, or my standard form answer, is less than 1. Okay, it's going to be a small positive number. And then the last example I'm going to do would be something like 4 times 10 to the 5th. I have a positive exponent. It means my standard form number is actually very large, okay, larger than 1. So if I have the number 4, the way to make that larger would be if I take this decimal at the end, okay, and I move it to the right. So I'd move 1, 2, 3, 4, 5. And then I just fill in with zeros. So again, I started with 4. I moved my decimal 5 times. And because it's a positive exponent, it meant my standard form, or my standard notation number, was larger than 1. And so I need to move the decimal to the right. If I moved it to the left, that would create a number smaller than 1. And that's not what that exponent means for me. So I'm going to add in 1, 2, 3, 4, 5 zeros. And I always want to add in my commas, so that's written correctly. Count 3 from the back, 1, 2, 3, and throw that comma in there. And so that's what a positive exponent in a number in scientific notation would look like as the end result. Okay, so that's just kind of that overview of the things you learned about scientific notation from Unit 7. Okay. Now we're going to get into all these other things out of the way. What does it look like to add or subtract or multiply or divide numbers that are in scientific notation? So I've made this little kind of cheat sheet for myself of notes to share with all of you. I just want to kind of focus 2 pieces at a time, okay? So the first thing I'm going to focus on is multiplication and division. And if you remember at the beginning of this video, I said those laws of exponents that you learned in the first 5 lessons were going to come back and be really important to us, okay? And so I said that law of exponents about bases being the same. We would add our exponent. And then in division, when we divide and our bases are the same, we're going to subtract our exponents. So that comes up again when we do scientific notation operations, okay? And again, the 4 basic operations: addition, subtraction, multiplication, and division. So when I multiply numbers that are written in scientific notation, the first thing I need to do is multiply the coefficients. And when I'm talking about a coefficient, I'm talking about these numbers in front of the multiplication symbol, okay? So for this first one, I need to multiply 1.14, or 1 and 1400ths, and I need to multiply 1 and 9/10, those 2 coefficients, okay? So you would likely use a calculator for this, that's fine. And when I multiply these 2 numbers, okay, I'm going to get 2.166. And then I'm going to put my multiplication symbol. And my step 2 is to add the exponents. And this is going back to those laws of exponents. Okay, so when I have a base that is the same, 10 and 10, and I'm multiplying between all these pieces, I simply add my 2 exponents. So I would take 10 to the power of 3 plus 2. So I'm going to rewrite this and simplify this expression here. So 3 plus 2 is 5. And now I've multiplied the coefficients. I've added the exponents. And your final step every time you do these operations in scientific notation is just make sure at the end your number is still in correct scientific notation. So sometimes when you're multiplying different numbers, you might end up with 2 numbers in front of the decimal. You might end up with nothing in front of the decimal other than the 0. So then you might need to manipulate a little bit, move your decimal and your exponents so that your final answer is in correct scientific notation. This one worked out nicely. It has all the pieces, so we can move on. Let's look at division. Okay. So dividing numbers in scientific notation is a little bit similar to multiplication in that we start with just performing the operation on the coefficients. Okay, so if I have 8 and 8/10 times 10 to the second power, and I have 2 and 2/10 times 10 to the -1 as the power, okay, the first thing I'm going to do is divide those coefficients, those numbers in front of the multiplication sign. So if I take 8 and 8/10 and I divide it by 2 and 2/10, it works out nicely to get a 4. Okay. Now I need to deal with this part of my scientific notation. Okay. Now our law of exponents was that whenever we are dividing, right, whenever we divide and the base is the same, we subtract those exponents. So that's what we're going to do. So we have 4 times 10, and I'm going to take my first exponent, which was 2, the exponent in my numerator, and I'm going to subtract the exponent in my denominator. In this case, it's -1. So I'm actually taking 2 minus -1. Okay. So whenever we subtract a negative or take the opposite of, okay, that can also be represented with addition. Okay, so this is now 2 plus 1. So my final answer is going to be 4 times 10 to the power of 3. Now, my final step, I just want to make sure that my final answer is in correct scientific notation. So the only number that is in front of the decimal is 4. If you wanted to write it as 4.0, you could, all right? But the important thing is that you only have one number there. And then I'm multiplying, I have my multiplication sign, and I have my power of 10. So you might write this 4.0 times 10 to the third, or you might just write it as 4 times 10 to the third. Okay, either way would be acceptable. Just give you a minute to look at that again. That's multiplication and division for numbers in scientific notation. The last thing I'm going to go over with you today is addition and subtraction for numbers in scientific notation. Okay. Addition and subtraction, they start out in a similar way. Okay. Your very first step when you add or subtract numbers in scientific notation is it's imperative, it's really important that you rewrite any numbers when the exponents are different. Okay, so rewrite so that all your numbers have the same exponent or the same power of 10. That step is the same for both addition and subtraction. Okay, we can't do anything, we can't add or subtract until we have the same exponent for all of our pieces, okay, our scientific notation numbers. So if you notice here in my example, I have 2 3/10 times 10 to the 5th, and then I have 3 6/10 times 10 to the 6th power, okay? Now, if my powers were the same, I could just move on to step 2, but I do not have the same powers. This one is a power of 5, and this one is a power of 6. So let's go ahead and rewrite so that all of our numbers have the same exponent. Our power of 10 is the same for both. It's your choice. You could decide to rewrite them so that they each have a power of 5. Your power of 10 is raised to an exponent of 5, or for them to be 10 to the power of 6. Okay, that's really up to you. You could pick something totally different. Okay, what's important is that when you rearrange or rewrite your numbers, that they have the same power of 10. Okay, so here I'm just going to go ahead and, for the sake of my example, I'm going to make both of these into a power of 5. Okay, I'm going to actually pull back something else I showed you, because I think this power of 10 information is really going to help. So we said we want to make this, well, I want to make this into 10 to the power of 5. So my first number is already like that. So 2 3/10 times 10 to the power of 5. Great. Plus, now I want to decrease my exponent. Okay, and when I decrease my exponent, that means my decimal was moved to the right. So I'm going to move my decimal 1 to the right because I want this 10 to the power of 6 to drop down 1 number so that it's 10 to the power of 5. So now I have 36 times 10 to the power of 5. So that's step 1. You can skip this step if your numbers already have the same exponent for your base 10. So step 1 is complete. Now it says just add the coefficients. Now that my numbers, my base of 10 is raised to the same power of 5, all I need to do is add the coefficient, that number in front of the multiplication sign. All right, so I add 2 3/10 plus 36, and I would end up with 38 3/10 times 10 to the 5, the power of 5. If you think about multiplication and division, I said that last step is really important. We need to make sure that our answer is in correct scientific notation. This is a great example because this is not, okay? So I did all of my steps, but something forced my answer to no longer be in correct scientific notation. So we can fix that, not a big deal. We need to move our decimal 1 place to the left, so the 3 is the only thing in front of the decimal. And I moved it to the left, which increases my exponent. So I moved it once, so I have to increase my exponent 1. So that 10 to the 5th now becomes 10 to the 6th. Now I have all my pieces, and I'm set to move on. That would be my final answer in correct scientific notation. Subtraction starts in a similar way. Okay, if I have 2 numbers, and I notice that my exponent for my power of 10 is not the same, I need to rewrite it so that they are the same. Okay, I need that exponent to be the same. Again, it's your choice. You can either rewrite this number so you end up with 10 to the power of 4, or you can rewrite this first number so that both of your numbers in scientific notation are 10 to the power of 2. For this example, I am going to make both of them 10 to the power of 2. I'm going to leave this one alone. And I am going to rewrite this first number. I have 8, 10 to the power of 4, but I need to decrease it from 4 down to 2. So I'm going to move my decimal to the right. So I'm going to shift the decimal that would be at the end of 8 2 times. Okay, because I need it to go from 10 to the 4th, drop it down 2 times so that it's 10 to the 2nd. Okay. So this would be 800 times 10 to the 2nd. I'm doing subtraction, so I'm just going to follow this operation here, subtraction, and subtract my 2 coefficients. So I'm taking 800 and I'm subtracting 2 7/10. And when I do that, again, you would likely use your calculator. That's fine, and you can do that on the test as well. 800 minus 2 7/10 gives me 797 3/10. And then that times 10 to the 2nd power comes along for the ride. So I've completed step 1, I've completed step 2, but I'm never finished until I make sure that my final answer is in correct scientific notation. So the problem here is that I have 3 numbers in front of the decimal and I should only have 1. So I'm going to need to move my decimal until that happens. So right now 797 are all in front of the decimal, but I need to just have this first 7. So I'm going to move my decimal 1, 2 places so that that first step of scientific notation is taken care of. 1 number in front of the decimal times 10, and I shifted my decimal to the left, which increases the exponent. So each time I move it to the left, my exponent is going to increase by 1. So if I had 10 to the 2nd power, moving it this first time made it 10 to the 3rd power. Moving it 1 more time increased it to 10 to the 4th power. So now I have all 3 pieces of scientific notation, and that's my final answer. So I know that this was a lot, but hopefully it was review for the most part, or maybe I explained it a little bit differently than you saw in Mr. Morgan's videos or you watched on Khan. And so maybe this is just a different way for you to think about it. Maybe this way is easier. Maybe you found a method that Mr. Morgan used to be easier. Maybe you found something you learned in Khan Academy to be a little bit easier. But this is just an overview of a lot of the things that you learned in all the lessons in Unit 7. So that was just some information I wanted to go over for all of you to have access to before you take your test today. Your quiz 2 really involved this idea of the different operations for scientific notation. So I understand, and I would love it if you would go back and redo your quiz 2 from Unit 7 in Khan if you aren't happy with your grade or you feel like you could do better now that you have this information. And I would love for you to do that. You can certainly do that even before you take your test on Khan Academy today, just so you feel really confident with the material. And then just as with everything in Khan, if you retake it after the due date, or if you complete it after the due date, maybe you didn't get a chance to do it yesterday when it was assigned, just send me an email letting me know that you completed it or you redid it so that I can go back in and access your score, and then I'll update Elluminate. So keep in mind those Khan Academy, all of the assignment quizzes, everything in there you can keep redoing until you get the score that you want, because the goal is that you show me that you can do these things that unfortunately I can't be in the classroom to do with you. So keep that in mind. Also with Khan Academy, since your test is due today, it is this, at whatever point you want to take it, this morning or the afternoon. Anytime you use a hint, it will allow you to do that, but then it will not count that question correct in your final score. So keep that in mind. Use your notes, use your book. Certainly come to office hours today from 11 to 12 if there's anything I can do to help. And then as a reminder, you're going to have some review activities in Khan tomorrow. And then you have a Google Form assessment on Friday. And then hopefully you all have been getting some packages in the mail because you are getting your Unit 6 and your Unit 8 workbooks. Thank the front office staff and Mr. Paniagua for making sure that those all got mailed out to you, because next week we are going to start Unit 8. So we're ready to move on. All right, I hope to see you all at office hours. If there's anything from this video, make sure you just kind of rewind it, look back, watch it again, anything that might help you so that you are ready for your test today. I can't wait to see how well you all do. And I will